Can a simulation teach distributed systems better than a textbook? Here is an idea I have been exploring. Imagine a virtual business with one warehouse and several sales channels. A website, a marketplace, and a storefront. Customers place orders. Inventory arrives. Returns get processed. And every single channel keeps its own view of how much inventory is actually available. Now add the real world into that picture. Network latency slows messages down. Queues build up behind traffic spikes. Workers cannot keep pace with demand. Retries pile on top of retries. Duplicate messages sneak through. And updates arrive out of order. Instead of just reading about ideas like eventual consistency or idempotency, you could watch them happen. A deterministic simulation where every experiment can be reproduced with the same workload and the same random seed every time. Here's the twist though. The inventory number is not actually the lesson. The real lesson is watching how independent systems behave when they are all racing to stay synchronized with one source of truth. Picture it laid out step by step. An authoritative ledger holds every event in order. Stock received, orders placed, returns processed. That ledger feeds a synchronization layer, a message queue backed by workers, pushing updates out to each channel, and each channel ends up with its own projection, its own version of the truth, a few seconds or a few minutes behind. In one experiment, a traffic spike hits at minute 10, queue depth rockets past 150 messages. The website's synchronization lag climbs past 90 seconds. Amazon's lag peaks near a minute and a half. And it takes over an hour for everything to fully settle back down. That gap between real and reported inventory is not just a graph. It is where the business risk lives. A customer sees in stock on Amazon. The order gets accepted. But the warehouse already sold that unit somewhere else. That is an oversell, and it happened because two systems were both right and both wrong at the same moment. So the questions stop being thought exercises and start becoming experiments you can actually run. How long does stale inventory linger after a spike? When does adding more workers stop helping? What do duplicate messages do to correctness? Why do sequence numbers stop an old update from overwriting a newer one? And under what conditions does staleness turn into an actual oversold order? I think there is real value in turning architecture concepts like these into something engineers can observe, measure, and repeat, not just something they discuss in a diagram. So I will ask you the same thing I am asking myself. Have you seen simulations built for teaching distributed systems this way? Or have you mostly learned these lessons the hard way in production?